Intro to Multiplying Matrices by Ahazz. Rules for multiplying matrices. So, to understand what multiplying matrices means, so I'm just assuming that you know what a matrix is. So there is scalar multiplication of matrices, and then there is multiplying matrices. So scalar would be you take a real number, let's say 3, and then you have matrix B, which is just matrix B. So whatever values you have for matrix B, to scalar multiply it, you would multiply it by 3. So then it would be matrix 3B, and then every value inside the original matrix B would be multiplied by 3. So if you had a value of 2 in matrix B, it'd be 6 after you scalar multiply. But this is multiplying matrices. So multiplying matrices would be multiplying a matrix A by matrix B, or matrix X by matrix Y, or whatever you want. Matrix and the rules for multiplying matrices would be these following ones. Matrix A's number of columns must be equivalent to matrix B's number of rows, or vice versa. So matrix A's number of rows and matrix B's number of columns, they just have to be equal. Matrix A multiplied by matrix B does not always have to equal matrix B times matrix A, because they are matrices. They are in a different order. Maybe. I'm not sure. It's just an example. So the steps to multiplying matrices would be: A. Multiply the first row / column of matrix A by matrix B's first row / column. And then you take the same row or column of matrix A, you multiply that by the second row or column of matrix B. And then you repeat the process for the second row of matrix A. First row / column, second row / column. Then you add all the products together. So by adding, it would be like whatever answer you get. So first row, first column. So 7 times 1, and then 5 times 4, and then 2 times 9. So 7 times 1 is 7, 5 times 4 is 20. 7 plus 20, 27. And then 27 plus 18 would be 45. Now I have to work on this slide right here. So 7 times 1, 7, 5 times 4, 20, 2 times 9, 18. So that's first row, first column, and then first row, second column right here. Second row, first column right here. Second row, second column right here. And so by adding all the products together, you would get this own value of your matrix. So this would be 45, this would be 46, this would be 63, and this should be 60. So 45, 46, 63, and 60, just like in the example. So real-life application of matrices would be, physics, as in electrical circuits, so the wiring in your walls, the wiring in the computer, or whatever you're watching this with, like that. Matrices have something to do with that. Quantum mechanics, stuff like that's like hadrons, the real tiny stuff. Quantum foam, string theory, excitations, mostly theoretical stuff. Optics, such as light, so how light bends. Matrices have to do that. Everything that's pretty cool and important, matrices are involved. Coding and programming, to make something go from 2D to 3D in a modeling software, matrices are involved. And encryption, this is a big real-life application of matrices. So let's say you have a data string of binaries and you want to encode it. You'd use a matrix. It's supposedly randomly generated matrix, and so it'd be pretty tough to replicate for someone to decrypt it. So next time you're using modeling software such as AutoCAD, or you're decrypting something with a matrix, or you're studying quantum mechanics, think about it. Matrices, they're pretty cool, pretty important, and they're pretty fun.